Good afternoon, guys. I've been asked to actually revise this a little bit, which is analytical geometry. I'm gonna go through it quickly. If you really want the slow version, we'll play it using a slow motion button, or just try to rewind if I went through something quickly. Now, first actually, the gradient determines the slope of the graph. We spoke about that. The gradient is calculated by the difference between 2 points on the line, which is y values divided by the difference of the same 2 points, which are your x values. Alright, if the curve slopes down, its gradient will be negative. Alright, if the curve slopes down, its gradient will be negative. Just like that. That's how your straight line will be sloping down, and if the curve slopes up, the gradient will be positive. And this is how we calculate the gradient. It is always change in y divided by change in x, and that's how your graph will slope up. Right now, if your straight line graph looks like that, it'll have a positive gradient. Now, deduction of a formula for the gradient of a straight line. Please note that if I have point A and point B, for me to calculate a gradient of AB, I will simply take y of A minus y of B divided by x of A minus x of B. I did emphasize this when we went through this, that these must be the coordinates of the same point, and these must be the coordinates of the same point. Okay, if you have ya, if you started with ya in the numerator, in the denominator you must have xa. If you have yb in the numerator, in the denominator you must have xb. And that's what the gradient is. It is simply a change in y divided by change in x. Now let us calculate the gradients of the following points. We do have x and y values and the coordinates of a and b. For us to calculate the gradient of AB, I will simply take y of a, which is -1, minus y of b, which is 5, or you can simply use that formula. But because what I did here was simply this minus that, that's why I have 5 minus -1. Obviously that will turn out to be positive, and you'll have 6 over minus 5. Now you realize that the gradient is negative, means that your graph is sloping down. A negative gradient means your graph will slope down, so your graph must look like that, and you realize that AB is actually sloping down. Now please do this as a classwork. Do other points, calculate the gradient of the other point. Okay, I actually did a remedial for you. Now if I was to calculate the gradient of CD, it's the same thing. Gradient of C, D will simply be y of C minus y of D, or you can simply say y2 minus y1 divided by x2 minus x1. And I took 3 and I minus -2, that will turn out to be positive, and I took 0 minus -1, that will also turn out to be positive. That's why in the numerator you'll have 5 over 1, which is your denominator, and the gradient of CD is simply 5. The gradient of EF will simply be change in y all over change in x, which is y of E minus y of F, and divided by x of E minus x of F, which is simply 1 minus 2 divided by minus 4 minus 6, which will give me -1 over -10, and that will be 1 over 10. Now here is what you need to remember about parallel lines. If lines are parallel, they will have equal gradients. If AB is parallel to CD, then it means that the gradient of AB will be the same as the gradient of CD. That's what it is. To prove that the lines are parallel, all you have to prove is that their gradients will be equal. Okay. Now all you have to do is to calculate the gradients of those lines and make sure that they're equal. If they're equal, it means that those lines will be parallel. Let's calculate the gradient of AB and CD. When you calculate the gradient of AB, I will simply say y2 minus y1 divided by x2 minus x1, which will be 5 minus negative 2 and minus 2 minus negative 6, and that will give you 7 over 4, and that is the gradient of AB. Let's check what we will get as the gradient of CD, which is y2 minus y1. I took 4 minus negative 3, 3 minus negative 1, and that gave me 7 over 4, which is the same as the gradient of AB. That's why we're going to say that CD is actually parallel to AB because they have the same gradient. And that is what it is, okay? For collinear points, you treat collinear points just like you treat parallel lines. Collinear points will always have equal gradients. So if for us to prove that these points are collinear, we'll simply calculate their gradients. I will start with the gradient of AB. It's up to you which points you start with. As long as the gradients of those points are the same, then you can conclude that those points are actually collinear. I started with AB, obviously, which is 5 minus 2 divided by 1 minus negative 2. So basically, and hence I have 5 minus 2 is 3. In the denominator I also have 3, and my gradient will simply be 1. And then I will simply calculate the gradient of BC, and the gradient of BC will be will be 2 minus negative 3 and minus 2 minus negative 7, and that will give me 5 over 5, which is simply 1. Okay, that is the gradient of BC. I don't know why I keep on writing AB. That is BC. Now, since the gradient of BC is the same as the gradient of AB, we can conclude that those points are collinear. And we did one of these. Please check your classwork where you had to calculate x. Please make sure you understand that as well, when points are collinear or when points are simply parallel. For perpendicular lines, lines are said to be perpendicular if they create a right angle, which is a 90-degree at the point of intersection. If AB is perpendicular to CD, then when I calculate the gradient of AB and I multiply it with the gradient of CD, I should get negative 1. If the lines are perpendicular, then the product of their gradients will be negative 1. Okay, for instance, here I will first start by calculating the gradient of AB and calculate the gradient of CE separately. And when I multiply those two gradients, I get negative 1. It means that the line AB will be perpendicular to the line DE. And obviously realize that AB simply equals to 1. Therefore, it means that DE should give me negative 1. And it does. So when you multiply the gradient of AB with the gradient of DE, it should give you negative 1. If they give you negative 1, we can conclude that AB is perpendicular to DE.